So what we have here is core that's fitted into a meter long core tray. You can get longer core trays. Typically they put them into 1.5 meter long core trays. Okay, what is needed before you start logging is typically they have a technician make sure that all the core fits together. Okay, so somebody who doesn't have an honors degree will go along and fit all the pieces together and make sure they fit. Okay, pretty menial job, but this is the consequence of it. So they have to make sure it fits together, that it's all lined up. In other words, they want to check that all the core is there, okay, and that they're not missing pieces. So typically what they will do is they will use a Kleiner rule and they will draw a straight line across, and then also take the piece at the end, okay, maybe I'll take a shorter piece, and they'll make sure that that sort of fits together with that piece.
So it's a continuation.
Yeah, continuation, to make sure it is all right.
Okay.
Okay, now this size of core is what is called NQ, okay, because there's different sizes of core that are drilled. Okay, NQ has got a diameter of 46.5 millimeters, if I remember correctly. Typically when they start drilling, they will drill at a larger diameter called BQ, okay, because they're going through typically wetted, soft, broken up ground, and they need to get through that. So they use a large diameter core or drill piece to get through that. Once they've got through the wetted ground, depends on how deeply wetted the area is, they will switch to this core, okay, which is the typical core size that you normally see. Okay, but if they run into problems, or if the drill bit gets stuck, they will switch to the smaller core. Also, what happens is once they've drilled through the wetted material, they actually have to, I can't remember the name now, but they actually have to put in a collar. Yeah, they have to collar it to ensure that all the wetted material doesn't fall into the hole, okay, from the top piece. Okay, so they have to collar it.
It's basically a tube.
Yeah, a tube. It's like a concrete or metal tube that they put in for, say, 2-3 meters, or if it's more, deeply wetted down to 5-6 meters, just to make sure that the hole is secure and doesn't actually cave in. Okay, now when the driller is drilling, typically the driller gets paid per meter, okay, drilled. And so they will want to drill as quickly as possible without any consideration as to quality that they're actually drilling often. Okay, so
They have no degree.
it is a bit of a skill actually, it's quite an art. Really good drillers are hard to come by. But I don't think we've got any examples laid out, but sometimes they actually drill it too fast and the diameter of the core gets reduced to a smaller size, or they actually go through portions where you're getting a lot of fracturing or shearing, and they actually drill through that too fast and you lose core, and so you end up with core loss. Okay, that is why somebody actually has to go along and make sure all the pieces fit and measure it. Now all these little yellow blocks in here are called meter markers. Okay, and you can see that they've got a depth on them. Okay, for example, in this case, 33.75.
Okay.
Okay, that is actually supposed to be put in by the driller. They actually, on their drill machine, they have a depth counter. So they can only drill 6 meters at a time before they have to actually bring up the core. Okay, otherwise they can't go deeper than that. So after 6, so you'll see that these are spaced typically every 3 meters apart. Okay, you see here 52.81 on this one. The next one is 55.82. So if they do their job properly, the meter markers should be 3 meters apart. You can already see on this one 33.75, 36.50. Okay, so it's a bit of a, so you actually have to check. What is typically done is you will take a meter marker, say towards the top of your hole, okay, and take that as almost like your baseline or your datum, I suppose you could call it. Okay, and make all your measurements from there. So you'll assume that some meter marker is accurate. The depth that's recorded there is accurate, and then you will measure from there out. Okay, so once all your core is basically lined up and fits together neatly, you will take note of that depth. Okay, 52.81, and then you will start measuring out from there. Okay, basically marking off, or the technician should actually mark off the meters for you. That's his or her job. Okay, and you can carry on measuring, and if it's correct, hopefully by the time you get to that meter marker, 55.82, that is what you should have measured. Okay, does that make sense? Okay, but if there is a discrepancy, then you have to check. Maybe there is some sort of core loss or something like that, or the driller didn't actually take account of what is drilled. Okay, so you actually need to mark that in your log. Okay, now you'll see that there are breaks here in the actual core. Some of that is actually man-made. In other words, they broke the core to actually fit it in, or it is actually done during the drilling process. Okay, the core got broken up as they pulled it out or as they put it into the core tray. But others, like for example that, you can see is actually natural. Okay, so those are sort of the things you need to take note of and measure. So when you log in, you'll basically take your measurements along the center line of the core. Okay, so if you should happen to find a contact or a joint or a fracture, you actually measure it where it intersects the center line of the core rather than the edge of the core. Okay, and that's basically what everybody does, just so there's consistency in the way that they record and measure contacts or jointing or fractures within the actual core. Okay, so for example, you will take a look at the core to take a note of what you normally do, like in the field: grain size, mineralogy, textures, alterations. Typically mining companies have their own sets of codes. You have like a log sheet, and then you'll fill out each of the column in turn for each different lithology that you have, and they just enter that into a big database, and they know that once they enter in those codes, it'll basically give them symbols so they can plot up the core logs. Okay, so for this exercise you can basically, we need to wet it so you can actually see clearly what's going on, but you can actually log the different contacts between different lithologies. Okay, that's the first exercise. You can note changes in grain size. For example, you'll be able to see that, for example, it's going from coarse grain to a more finer grained variety. Okay, things always look better when they're wet, obviously. Well, not everything.
They don't have running water. When they don't have running water, they pee on it.
Are you serious?
Okay, so for example, you would take note of any sort of contacts. So yeah, you're getting more coarse-grained, garnet-rich type of feldspathic nice. Yeah, it seems to be more biotite rich. So you'd actually make note of that contact. It seems to be almost gradational, and then gradational into a more sort of coarser grain thing. So those are the sorts of observations you need to take note of. Okay. Also, don't get too carried away in recording every single little variation you're going to see. Obviously, rocks within themselves can show quite a bit of a variation. So it's more like the major sorts of contacts,
What
say
stands
like
out?
there, and there's another one more or less over there. Okay, and that might be considered differently to that.
Which side?
Okay, and obviously this is different. Huh? Okay, well luckily Mark's doing a video blog. Okay, is everybody... Well, basically as well, when you split up into your 5 little groups, we can actually go through it again and tell you, for those of you in the background who can't see. Okay, obviously because they drill, because they're looking for mineralization, you obviously have to take notes of any form of alteration. That's very important. Okay, whether it's chloratization or serpentinization or whatever. Okay, then for structural or geotechnical reasons, you also need to take note of joints or fractures or veins or things like that, because like I said earlier, they actually will have an influence on the stability of your stope or your pit slope. Okay, so you'd have to take notes of, for example, features like that, and you obviously would record where the start of it is and where the end of it is. Okay, and you'd also take notes of the angle at which it's intersecting your core. So you actually do have the little clinometer on your clino rule, so you can actually record the angle that it's making with your core. Okay, so for example, like that, this is making an angle of 20 degrees with your core. Okay, hopefully the people who drill it know what angle they've drilled it at. Okay, you can drill a core at 90 degrees, in other words vertically down, at 45 or at 60. Underground, sometimes they actually drill it horizontally. Okay, if they're doing advanced drilling ahead of where they're going to mine. Okay, you also need to take note of the spacing between the joints. Okay, for example, in this case, you're seeing a bit of a joint set there, and they are spaced more or less like a centimeter apart, more or less. And you should also take note of what sort of filling actually is filling the joint or the fracture. Is it chlorite? Is it serpentine? Is it clays? That sort of thing. And the roughness of the joint. Is it smooth? Is it sort of jagged? Things like that, because that again influences whether it will slip or whether it will basically stand up once they've lost. Okay, and any sort of filling like in a vein, whether it's calcite or quartz or things like that. Okay, is there anything else I need to tell you? Okay, maybe we can move across to the core that's cut.